Welcome to the University of Florida's Powell Family Structures and Materials Laboratory. Windstorm research at the University of Florida dates back to the early 1950s, although as you'll see, our current facilities are a little more state-of-the-art. Located on the university's east campus, the facility consists of approximately 20,000 square feet of lab space and houses the 5 major resources that have been proposed for the NHERI experimental facility. We view our NHERI EF not just as a best-in-class facility for performing transformative research, but as a turnkey solution which will help guide potential researchers through the process of vetting ideas, writing NSF proposals, preparing budgets, administering projects, and conducting experiments. After discussing project ideas with UFPIs, researchers are invited on a tour of the facility to advance their project development. Safety is a preeminent concern at the Powell Lab. All visitors, students, and staff working throughout the facility are required to complete safety orientation training and wear appropriate safety equipment and identification. PIs and lab management have access to 22 IP cameras that provide live feeds covering every corner of the facility. NHERI PIs will have web-based access to the same resources. The Powell Lab is a full-service multi-hazard laboratory that is supported by a wide range of services for experimental testing and cyber infrastructure. We have more than 24 National Instruments data acquisition systems, including compact RIO and PXI systems, and more than 200 instruments ranging from strain measurement devices to optical disrometers. Devices are stored in the instrumentation room or in an accompanying storage area when not in service. Now, the backbone of this system is a live, cloud-based inventorying tool that uses barcode technology to track items as they arrive, are deployed, or taken out of service for calibration and repairs. The facility is equipped for a wide range of fabrication services, ranging from 3D printing of wind tunnel models to metalworking to construction of full-scale house mock-ups. Our machine shop has more than 20 pieces of equipment and a dedicated machinist with more than 50 years of experience, most of it in an academic research setting. At the back of the main high bay facility sits the multi-axis wind load simulator, or MALS. The MALS is capable of creating dynamic wind pressure, uplift and shear loads associated with a Category 5 hurricane on any size building, and EF5 tornadoes on low-rise buildings. The system's 1,800 horsepower diesel prime mover powers a 14-foot centrifugal fan, which is capable of producing 460 pounds per square foot at 100,000 CFM of leakage, through specimens as large as 18 feet by 24 feet. In 2014, the lab added 30-ton hydraulic jacks to apply in-plane loads, both in upload and shear. The pressure chamber is reinforced concrete with 13 tons of mild steel and post-tensioning, and a removable reaction frame that was specially designed to resist large catenary forces. Dampers in the ducts can be adjusted to bypass this chamber and drive air through a high-speed wind tunnel located next to the power generation system. The Dynamic Flow Simulator, or DFS, can simulate wind speeds in excess of 230 miles per hour across building surfaces to replicate wind effects on discontinuous component and cladding. The combined capabilities of these systems make it possible to test building systems to their failure limit. The Annex, built in 2012, houses the other experimental resources and 4 multi-use bays, which are available as needed for staging or experimentation. Each bay has its own dedicated computer station as well as access to all of the resources in the facility, including connections to the HyperGator supercomputer. The High Airflow Pressure Loading Actuator, or HAPLA, can be thought of as a means to replicate naturally occurring pressure in a controlled laboratory environment. For example, UF field studies have measured the dynamic pressure on building surfaces during landfalling hurricanes. The HAPLA can replay these pressure sequences in their entirety. The system was developed in collaboration with the University of Western Ontario and is based on the $8 million Three Little Pigs project, which represents the state-of-the-art and physical simulation of dynamic wind loads. The system can also replicate time-varying wind-driven rain conditions to characterize building envelope performance in severe weather. The Spatiotemporal Pressure Loading Actuator, or SPLA, advances the same concept to simulate spatially varying loads across multiple zones on a roof or a wall system. The SPLA can accommodate up to a 12-foot by 24-foot specimen. While the SPLA and HAPLA are excellent tools for independent experimentation, they are also valuable to perform tests on large numbers of replicates to characterize uncertainties, perform Bernoulli trials for fragility modeling, or to narrow experimental parameters before running full-scale experiments on the much larger MALS. As we make our way through the multi-purpose space, we come to the control room for our new state-of-the-art boundary layer wind tunnel. The second largest of its kind in the U.S., the wind tunnel features a unique automated system to control the height and aspect ratio of more than 1,100 individual roughness elements providing unprecedented granularity in the control and tuning of approach flow conditions. The roughness element configuration can be changed on the fly to alter both terrain and geometric scale over a wide range of regimes. Adding this unique technology to a traditional boundary layer wind tunnel backbone harnesses the full investigative value of this tool and opens a path to transformative wind engineering research for NSF program utilization. This facility is also supported by a wide range of specialized measurement devices, including a 512-channel pressure scanning system, Cobra probes, particle image velocimetry, and a high-frequency force balance. The Powell Lab is adjacent to the university's new high-performance computing facility, which houses the HyperGator platform and long-term replicated storage that will connect to the NHERI network. A user can integrate the computational power of the 150 teraflop HyperGator into her or his experiment with ease. While visiting the facility, researchers are encouraged to use our conference space to dive deeper into potential research areas and to discuss preparation of NSF proposals and budgeting to help get their research project approved. For NSF researchers spending significant time at the facility, the university has provided co-located office space for their teams. Education and training will be integrated into a series of webinars and classroom training sessions to enhance the scientific literacy of students and teachers and assist users with developing proposals and experimental work plans, as well as successfully executing projects. Dedicated classroom spaces are available to facilitate the education of both small and large groups. In addition, the experimental facility will be used for hands-on training workshops to spread awareness of the ongoing research being conducted. Thank you for taking the time to visit the University of Florida's Powell Family Structures and Materials Laboratory. We're looking forward to hosting your NSF research projects in the NHERI Experimental Facility.